Ben is someone who's been, I guess, really deep in the trenches in research and development capacity within Ethereum for a number of years now. He's also someone who, I chat to a lot, and just, really enjoy, our chances to catch up, because, he just knows a lot about the space, but also is just a great guy too. For those of you who haven't come across it as well, he publishes a regular sort of letter, really, that's online called What's New in ETH. And this is a fantastic resource if you want to just keep up with what's happening within, sorry, it's What's New in ETH 2, but it's really about what's happening in the world of R&D with respect to transition to the Ethereum beacon chain, which was the new network that was launched at the end of last year. So if you've not checked it out, I really encourage you to read it, because it's just such a fantastic way to keep up with what's happening in the ecosystem.
Thank you so much, Connor, for the very generous introduction. I enjoy talking to you as well. Let me share my screen. All right, so Connor's pretty much done the background and the introduction. So I've been with ConsenSys for about 4 years, and ConsenSys, I'm sure you know, is the largest blockchain or Ethereum software development organization around, and we do things like Infura, MetaMask, and also a lot of protocol work, and I sit in the protocols group formerly known as Pegasus. And today I will give you an update on where we are with Ethereum 2.0. I haven't tuned this for an enterprise Ethereum audience. This is very much sort of mainnet focused, although I do have a few thoughts at the end to around the enterprise space, though it's not my speciality. This is my kind of disclaimer slide. I sometimes think that sort of mainnet Ethereum and enterprise Ethereum, it's a strange pairing, because the mainnet Ethereum world, we are almost self-consciously disorganized. We almost see it as a feature. We like lack of structure. We like to be permissionless. We like to be fully decentralized in terms not only of network architecture, but also in development work, communications. We have loose coordination. We don't write detailed roadmaps and so on and so forth. It's the bizarre model of open source software development, not this cathedral model, which is whereby designs are handed down from on high to people. So this is kind of by way of saying I don't speak. I'm not a spokesperson for Ethereum. I'm just a contributor. I'm a participant in an ecosystem in which hundreds or thousands of people are participating. So this perspective is my perspective, and I don't speak with any authority, so take it with a pinch of salt, but hopefully, given my involvement, it will be reasonably accurate. So quick take on where we are with Ethereum today. Put aside Ethereum 2, this is Ethereum. We've got good things going on. The network is in demand, and there are numbers. These numbers kind of change rapidly, so I won't go through them in detail, but basically people want to use Ethereum. It's getting it's got a lot of utility. People are prepared to spend money using it, and it's got this $250 billion market cap, which reflects the desirability of the network. So good stuff. I mean, it's come a long way in the very nearly 6 years since it was launched. But bad things as well. Gas prices, which is transaction pricing, are highly volatile. We had a spike last night. Some cat-related celebrity NFT thing shot gas prices up to about 700 gigaway, which is something like 30 plus times more than the kind of standard gas price at the moment. So everybody's transactions suffered at that time. It got enormously expensive to use the network. Normal transaction fees are around a couple of dollars per transaction at the moment, but they have peaked at 45 plus for average transactions in recent months, which is not where we want to be. This is not the goal of the world computer, the world settlement layer. We wish to be in the cents per transaction realm. And there's a lot of congestion. We've got 140,000 pending transactions as of an hour ago. If we stopped sending transactions, it would still take 4 hours just to drain that queue. So not everything is happy. You can probably see where I'm going with this: the good, the bad, the ugly. These are kind of contextless numbers, but running the Ethereum network takes a huge amount of power and has a huge carbon footprint. If Ethereum were a country, then it would be like 48th biggest user of power in the world, somewhere around Uzbekistan's power consumption at the moment. And this is just not sustainable or reasonable. So that's where we are today. I've stuck in some sort of takeaway slides just to punctuate the talk. So these are just little summaries of to give us a bit of a breather. The point is that we need to scale and we need to become sustainable. What's the plan then for sustainability and scalability? Sustainability, we plan to address by moving away from proof of work, which is using this enormous amount of energy, and moving to proof of stake, which is, estimates vary, but somewhere between 2,000 and 10,000 times more energy efficient than proof of work for similar security levels. And we need to become scalable. So Ethereum as it is doesn't have any scope for scalability any further. Ethereum 2.0 addresses this with sharding. So we parallelize some of the computation, but it's become a little more complicated than that. And I'll come back to that in a little while. But we have a scalability plan. And the goal is to deliver both of these, scalability and sustainability, whilst maintaining our Ethereum goodness, decentralization, censorship resistance, permissionlessness, resilience in the sense that the network keeps running, it's live, and safe in the sense that the network doesn't contradict itself, that it's correct at all times. Proof of work versus proof of stake. You may well be familiar with this. Ethereum has been on a trajectory towards proof of stake since long before it was launched. So since 2014 or so, we've been talking about proof of stake. And it just has much better properties than proof of work in almost every respect. For example, energy consumption is far lower. Finality is a feature of the protocol, which it isn't in proof of work. The only metric on which proof of work wins is on complexity. It is very simple. It's very easy to analyze. Proof of stake is much more complicated to implement and requires, as an order of magnitude, maybe 100 times more lines of code to implement. But the advantages far outweigh that disadvantage in my view. So here's a takeaway: proof of stake much better than proof of work. So we had a plan about this scalability and this sustainability. This is a historic plan, and it may still be what you have in mind for the Ethereum roadmap. It may be your mental model of where Ethereum's going, and it has changed. That's a spoiler, and we'll come to that in a moment. But just to give you the context and orientation, this is what it used to look like. So we've got proof of work chain, Ethereum 1, just keeps running for foreseeable future. And then alongside that, we're building this Ethereum 2 thing, starting with a proof of stake beacon chain, which it doesn't do anything. It just sustains itself. It is proof of stake, is how I like to look at it. And that just demonstrates that we can make this technology work. And then we add sharding to that proof of stake chain, and then we add an execution layer to the shards. And then after all of that, we bring over the proof of work chain onto Ethereum 2, the proof of stake chain, and turn off proof of work. So you can visualize it like, there's a little cart track, which is Ethereum 1, very limited capacity, very bumpy road. And alongside it, we're building a super highway. It's not open yet, but the two are operating in parallel. And at some point, all the traffic from the cart track will move over to the super highway. And that's the nice, clean roadmap that we previously had. with 3 phases: phase 0, phase 1, phase 2. A different view of it is, here's the existing Ethereum 1 chain, proof of work mainnet, producing blocks via proof of work. We build this beacon chain, this proof of stake chain alongside it, and it loosely couples to the proof of work chain. We just read deposit data. So when people put down a stake in Ether, we can read that data from the chain, but there's no other connection between them. And then we add these shard data chains. Originally, we were looking at 1,000, 1,024, now 64. And finally, we add, well, not quite finally, but then we add execution on top of that, which might or might not be EVM. It could be WASM. It could be arbitrary execution environments, could be lazy execution, functional languages, all sorts of possibilities. And then we turn off proof of work and import the proof of work chain state into this new model. So this was the original plan for the upgrade to ETH2. But as I mentioned, things have changed. We have ripped up that roadmap. Well, not quite, but to some extent. What has prompted this? Why have we deviated from that nice, clean and tidy roadmap? 2 reasons. First is increasing urgency around moving to proof of stake. On that timeline that we had, the proof of work chain was running for maybe several years, 2, 3, 4 years into the future. A number of factors have really prompted a pressure to turn off proof of work as soon as possible. We had this debate about implementing EIP 1559, which goes live next week. The miners didn't like it. They threatened all sorts of horrible things. They're not going to happen, but it's kind of set the community at odds with the miners. And the easiest way to deal with it is to get rid of them entirely. There were there continue to be all sorts of environmental question marks. So this nice tweet from Elon Musk about why they stopped accepting Bitcoin and so on. And we're just paying too much for security. You have to compensate miners for the electricity they're burning. We can do that much more cheaply in proof of stake. So there was an increasing urgency around turning off proof of work. And the second factor is that the scalability side, there were new paradigms emerge which make it a lot easier. So the previous plan, all of the scalability, that's the shards and the executable shards, was done inside the protocol at layer 1, as we call it, which is very restrictive. Around a year ago, we started moving towards what Vitalik calls a roll-up centric roadmap. So this new technology called rollups emerged, and they can scale Ethereum outside the protocol. So we call it a layer 2 technology. And I'll say a little more about that in a moment. And that relieves us protocol developers of a lot of burden, because we can basically let other people develop that. They can iterate it, they can experiment, they can do all sorts of things which is hard to do inside the protocol. They can do it layer 2 and achieve the scaling outside of the layer 1. And the other thing is, my colleague Mikhail Kalinin proposed a shortcut to getting to proof of stake, getting the EVM, Ethereum's virtual machine, onto the beacon chain. And this is what we decided to develop. Rather than waiting to the end of the process when we've delivered the sharding, the executable shards, we can actually short circuit that. And it turns out that the data sharding and rollups complement each other very nicely. So this is what the new plan looks like. We are more or less schematically where this orange line is. We have the proof of work chain is still running, and we started the proof of stake beacon chain 8 months ago, almost. And now we're going to do something which we're calling the merge. So the next milestone on the roadmap is when we turn off proof of work and we bring the proof of work chain onto the beacon chain and merge them. So I'll say more about that in a moment. And then we implement sharding, which is data sharding, but we don't do the executable sharding that was on the previous roadmap. And together, this merged system is Ethereum 2. I mean, it's scalable, it's sustainable. And we can just call it Ethereum because we're not delivering a new blockchain in the end. We are continuing the old blockchain, but we are swapping out the consensus mechanism and adding some scaling. So schematically, this is where we are today. This looks very similar to the previous diagram because it's the same. We have this proof of stake chain running that doesn't do much, just a beacon chain, and it links to the proof of work chain by watching the deposit contract. Next step is this merge. We turn off proof of work and we take the proof of work blocks and put them into the beacon chain. And that I'll explain a little more in a moment. And then next step, we add these data shards, and then we're finished. That's the full roadmap. So proof of stake, we brought it forward in the roadmap, and the shards are no longer executable. We're relying on the well-known EVM. Nothing changes. All of your smart contracts, all of your interfaces, all of your applications will just keep running as before because we're not changing the execution layer at all. I probably won't go into this in detail. This is about rollups. Let me just do a time check. Yeah, I just want to say that, so on the left is our current status on Ethereum 1. Everything is monolithic. We have one stream for data. This is your blocks, so transactions and blocks. We have a single execution engine, which is the EVM, and we have a monolithic state, which every node needs to manage. In order to scale, we need to parallelize these somehow. It's the only reasonable option. It's hard to speed them up in any meaningful way. So we gain by parallelizing. So the goal is to parallelize state and execution in rollups, which are layer 2, and parallelize the data, which is the blocks, in shards. So within the protocol, we have parallel data shards. So Ethereum will have 2 megabytes per second of data availability, which is about 500 times more than we have today. So the number of transactions or the amount of data you can put on chain will increase by 500 times, but that will be managed. The results of computing on that data will be managed outside the protocol in rollups. And then we have this security model whereby you have ZK rollups and optimistic rollups. They inherit the security of the beacon chain. There's a whole presentation on this slide alone. So that's all I'm going to say about that. We can do some Q&A if you like later. So scaling is achieved by a combination of data sharding in protocol, layer 1 sharding, and rollups outside the protocol. So it's a change in the roadmap. Rollups are the new feature here. So this is the roadmap again. The new version. We have a consensus layer, which is a beacon chain, and the ETH1 becomes our execution layer. Let me dive a little bit more deeply into this beacon chain side. So this is already running. We started it on the 1st of December last year. And this is what it looks like today. So we have 200,000 active validators managing the chain. We have 6,400,000 Ether. So to participate as a validator, you have to put down a stake of 32 Ether per validator. They have an average balance of 33 ETH because they've been earning rewards all this time. And we're onboarding new validators all the time. So that's going nicely. And, you know, that's current prices, I don't know, $15 billion worth of Ether getting on for. So that's a lot of security on this chain that doesn't actually do anything yet. Why would anyone stake their 32 ETH? It's a lot of ETH to stake and run a validator. Well, it's because you earn rewards. So there is no longer a block reward in the proof of stake world. You get a minor reward for a block, but most of your reward comes from voting on the state of the chain. In aggregate, your rewards add up to about 6.1% today. The amount of reward goes down as more and more validators join the system. So there should be an equilibrium at some point where APR, this is your gross return on your 32 ETH per year. At some point that'll drop below with a sort of risk-free return rate elsewhere, and people will stop joining, and we'll find an equilibrium probably somewhere, I don't know, around 10 million validators, I guess, which is plenty. Sorry, 10 million ether staked, which is 300,000 validators or so, which is, yeah, more than we need. There are many ways to stake with varying degrees of centralization and trustlessness. On the left-hand side, the most trustless and most centralized way to stake and participate in the beacon chain is by running your own client on your own hardware, which is what I do. My client is Teku, which is the client that I'm product owner for. Got to eat your own dog food. There are 3 others and a couple more coming on stream soon. And between us, we are maintaining this beacon chain. And then proceeding to the right, the solutions get more and more centralized until you end up at the sort of fully custodial, like the exchanges where you just put your ETH on and you have no control over it. You just have to trust them that they're going to stake it and return your ETH at some stage. And there are some subtleties about who owns which keys and whatever, but I won't go into that. The point is there's a sort of spectrum available for users who want to stake. So the takeaway, the proof of stake is running well in the form of the beacon chain. It's been 8 months and it's run superbly so far. So that's beacon chain bit. What about the merge? Quick word on that. This is kind of conceptually what it looks like, a logical diagram, not difficult. We just at some block, and that there is a sort of methodology for working out, at what point we will execute the merge. The 2 chains will decide to coalesce rather than run separately. We bring the beacon chain, the proof of stake chain, together with the proof of work chain, and we turn off proof of work, and then the beacon chain manages all of the Ethereum 1 blocks and transactions and so forth. In a bit more detail, so this is the kind of system architecture. So this is today. On the left, you have a mainnet ETH1 client, and on the right, you have a beacon chain ETH2 client, and basically they don't interact at all today. They're both running in parallel. The proof of work client, ETH1, maintaining proof of work chain, and the ETH2 client maintaining the proof of stake chain. And we just have this ETH2 client watches the deposit contract on the ETH1 chain so it can onboard new validators. And each side does its own thing. ETH1 clients, just do what they do. They gossip transactions, they gossip blocks, they discover each other. And they have a JSON RPC API and run the EVM. On the ETH2 side, we have a REST API, and we gossip attestations, which are votes for the state of the chain. We gossip blocks, we discover each other. We have validators, and we have a signing service. So in ETH2, actions are accountable, so validators are known in the system. They have a key, they sign their blocks, and they sign their votes, so that you can, if they behave badly, they can be punished by slashing. So that's today, basically 2 independent streams running together. How does this change when we do the merge? And what we're doing is a minimal viable merge. We're interfering with this diagram to the least extent we possibly can while still getting the job done. So almost nothing changes. We turn off proof of work. The ASIC is X'd out. We turn off block gossip on the ETH1 side, because ETH1 blocks are now included within the beacon chain blocks. And we put in place an API between the ETH1 side and the ETH2 side. So we rename them. ETH1 is now an execution client. It executes the transactions and manages the state. And on the beacon chain side, it's the ConsenSys client. So the ConsenSys is no longer proof of work, it's proof of stake. And so we put in this API between the two. ConsenSys client is driving. most of the time it's receiving blocks from the beacon chain network, and it will ask the execution clients to insert those blocks into its chain and update its state. Every now and again, the ETH2 client will be asked to propose a block, in which case it will ask the ETH1 client to build that block using the transactions that it's received over the Gossip network. So the bottom line is that if you're running Geth today, you'll still run Geth, and almost nothing will change. The same JSON RPC API is available, and it will seem very familiar indeed. You just couple it with an ETH2 client like Teku, which again, if you're running Teku today, almost nothing will change. The REST API will stay the same, and all of the other interfaces. So it really is a minimal viable merge. And this is designed to be almost totally transparent and non-disruptive to existing Ethereum applications and tools. The idea is that one block is executed by proof of work. So up to this point in time, everything's executed by proof of work. From that point on, by proof of stake, and you won't even notice a difference. All you'll notice is that blocks suddenly start coming regularly every 12 seconds instead of randomly, and that's it. And the other advantage of this is we just rebuilding on existing components. We don't have to rebuild an entire new Ethereum execution client. We just use the EVM and the ETH1 client as is. Where are we with this? What's progress towards the merge? Well, as of last week, we have an EIP 3675, which is detailed. That will be merged in soon, and there is discussion forum for that, so you can track progress if you like. We've run testnets already with different combinations. So the ConsenSys clients, the ETH2 clients, the Teku, Prism, Lighthouse, Nimbus. And on the ETH1 execution side, they're paired up in with Geth, Besu, Nethermind, in all the different combinations. We ran some test nets under this sort of rarenism banner, and everything went very nicely. So we're confident we can deliver this. When general consensus is Q1, Q2, 22. Dates are slippery. Going back to my very first slide, dates are slippery in the Ethereum world. Because of our decentralized governance and decision-making and development processes, it's hard to put, really tight deadlines on things. But gut feel of most people, including Vitalik, who is a notorious optimist, is first half of next year. So takeaway, it's happening. We are turning off proof of work. So that's summary. This is kind of where I traditionally end this presentation, but I just have a couple more slides. Yeah, and I've got 5 minutes. So I'll just say a few words about Enterprise Ethereum from where I sit. And, caveat is this is not my day job working on Enterprise Ethereum, though I have been hanging around ConsenSys and Pegasus for long enough that I've picked up a few things. So hopefully this makes some kind of sense. What if you are running a private permissioned enterprise network for some application? What are your options when it comes to Ethereum 2? And how are things going to change for you? Well, option one is basically don't change anything, just carry on as you do. As I've described, Ethereum 2 changes mainnet consensus by swapping out the consensus protocol. So we're basically just taking the proof of work engine out and putting a proof of stake engine in. And Quorum and other enterprise clients already do this. They just take standard Ethereum 1 clients and swap out the consensus, among other things. So in that sense, nothing changes. We're still going to be using Geth and Besu as our execution engines. So you carry on using them as your execution engines and carry on using IBFT, QBFT, or whatever Raft or whatever consensus mechanism you prefer. What about if you need to scale your application? well, Ethereum 2 scales mainnet with rollups and sharding. Enterprise Ethereum applications already scale much better than mainnet because you don't have this drag of proof of work. If you need faster scaling, then rollups is a good direction to go in. And we have something at ConsenSys that's in R&D called Sumo, soon to be in production, which is a rollup technology, which is very applicable to consortium networks. So one option is basically just carry on as you are. Other options, I like this one. I'm very keen on Mainnet and getting enterprises interacting with Ethereum Mainnet. Rollups are like sidechains, but they have much better security properties. They basically inherit the security of the base network, which in Ethereum's case is unsurpassed. We're already much more secure than Bitcoin in terms of the economic properties. And that will become even more so with proof of stake. So you have unparalleled security if you run a rollup. Rollups are very flexible in terms of what you can do with them, and it's perfectly okay to build a permissioned and private rollup, an enterprise rollup if you like. It can run whatever execution language you like. It doesn't have to be EVM. It can be any kind of WASM or Java or whatever nastiness you wish to indulge in. And the benefits are you have mainnet security and availability, and as mainnet implements sharding, you automatically gain a scalability boost in your rollup from the extra data availability on mainnet. Challenges of this are that data privacy, data has to go on mainnet. That's your transaction data. It could be encrypted for sure. That would be easy to implement in a permissioned rollup, but that might not be suitable for certain applications. Encrypting data might not be secure enough. ZK rollups are another interesting thing to look at in this context. And also, of course, because you're running on mainnet and benefiting from mainnet security, there is a real cost, though with the scalability from sharding, that cost should be very small. Otherwise, we're failed, but that may be an issue as well. So kind of, I think my takeaway from that is rollup technology is interesting, and as a path to interact with mainnet might be of interest to enterprise users. And final kind of option, I guess, is just to take Ethereum 2 as is, as I've described it. So you have an ETH2 client, ETH1 ConsenSys client, execution client. And rather than staying in the old world, you fully adopt the new paradigm. Proof of stake and proof of authority are not that different in the sense that you know who your participants are, and the consensus protocols are somewhat related. So you can treat proof of stake as a proof of authority protocol just by saying issuing staking tokens only to participants, and anyone who's not a participant doesn't have the tokens and can't stake on the network. So in that sense, you can emulate proof of authority on proof of stake. One of the problems is that proof of stake is horribly over-engineered for this application. We have all these rewards and penalties and slashing and things which are complex. So we could take an Ethereum 2 client and just set the rewards to 0 and remove that logic, much in the same way that Ethereum 1 clients have gas price set to 0 for enterprise applications and stuff like that. Benefit is that you can take a full advantage of scaling your enterprise application through sharding without having to go to mainnet, and you have a minimal architectural difference from mainnet, so you can potentially port applications across very easily. It's a bit hacky, much like kind of Go Quorum and Geth. You have to patch many things. It's not really designed for the enterprise use. You have to maintain modified clients. So those are my kind of naive thoughts on options from my perspective. I'm sure there are people in the room who have much better ideas. Last slide. As Connor mentioned, I do this What's New in ETH2 if you want to keep up with the very latest. I publish fortnightly at eth2.news. Next edition coming out late on Friday evening this week. And you can follow me on Twitter, Benjaminian_XYZ. And that's all from me.
Well, thanks, Ben. We've got a few questions here in the chat, which I'll run through. First of all, from Mike A, a simple question: can you explain how the ETH locked in ETH2 is able to earn income? Is this coming from the foundation for running the beacon chain, or are there real transactions occurring on the beacon chain for which you are being compensated for?
Right, so today there are no transactions on the beacon chain. The ETH rewards are generated in protocol. So just like the block reward in Ethereum 1 is generated out of nothing and given to miners, that's 2 ETH per block. So every time there is an attestation, which is a vote on the state of the chain in ETH2 on the beacon chain, or a block generated on the beacon chain, some reward is allocated in protocol. The validator balances are just increased. So this is inflation, technically. I mean, it's inflating the supply of Ether, but by a factor of 10 less than ETH1. So ETH1 issuance inflation is 2 ETH per block. It will be about 1/10 of that in ETH2. Hopefully that answers the question. After we've done the merge, validators will also earn transaction revenue. So anyone who transacts on the network will be paying network fees, and those will go to the validator, although after EIP 1559, a portion of that will be burnt as well.
I think, yeah, that answered his question. Someone was asking about the availability of the presentation. Of course, the video will be on our YouTube channel. In terms of the actual slide deck itself, is it something that you'd be willing to share? We could always post it to the Meetup group or something like that, Ben,
yep.
or...
Yeah, no problem. Happy to share. Yep. There are lots of links in there for if you want to follow through on anything.
Cool. And then a question from Yuri. I have a question about development on ETH2. It is known that storing data on the current Ethereum blockchain is expensive. How will this change on the new network, and how will using Solidity and smart contracts development change?
So the goal, taking the second part first, the goal is to be minimally disruptive. So all of Solidity and EVM execution, in at least for the foreseeable future, remains exactly the same. So all your contracts and so on should be fine. When we introduce sharding, we may have to introduce some new way to expose the shards to the EVM so that contracts can take advantage of the sharded data. That's a little complex. I won't go into it now, but at least in the short to medium term, no changes to applications or Solidity. In the remind me the first part of the question, Connor.
It is known that storing data on the current Ethereum blockchain is expensive.
Yeah, so the idea of the sharding is that we have 500 times more space to put data on chain. So up to that point, you know, when that becomes full, of course, the economics of supply and demand kick in. The hope is that 500x is enough for now, enough for a couple of years perhaps, and we can expand that in future potentially as, you know, Moore's law improves and so on. So hopefully the data availability bottleneck will be alleviated by just having this much more space within blocks, 500 times more space.
Macarand has asked, will the REST API and ETH2 make development easier, which I guess ties in with your
yeah, there's not much use to you if you're a developer. You will still be interacting with the JSON RPC API on the ETH1 side. So, you know, if you're running an ETH2 environment, you will have your ETH1 node, which might be Geth or Hyperledger Besu or whatever, and your application will interact with it in exactly the same way it does today via the JSON RPC API. Love it or hate it. On the ETH2 side, it's providing data about the beacon chain, which is not particularly useful to developers. So our JSON, our REST API has a different purpose.
Thanks, Ben. So, yeah, Ben, it's been great to host you, and I think if everyone could give Ben a virtual round of applause as well. So just off the back of what he said too, like from a personal perspective, I've been running Teku for well, I guess since the beacon chain launched. I've had no problems myself with it, so I can certainly also attest as a more neutral participant in terms of its quality there as well. So yeah, it's definitely worth checking out as an ETH2 client.